graphing the hunter Orion, I can describe components of the universe, including stars, nebulae, and galaxies, and use models such as the Hertzsprung-Russell diagram for star classification. We're going to watch a video on the constellation Orion below.
February, Tonight Sky, Constellations. The brightly starred winter sky beckons on clear, cold nights. Orion, the hunter of Greek mythology, dominates the heavens with a bright belt of 3 stars. The hunter's shoulder is marked by the red supergiant Betelgeuse, a massive star nearing the end of its life. Betelgeuse is roughly 1,000 times the size of our Sun. An image from NASA's Hubble Space Telescope shows its huge atmosphere with an enormous, mysterious spot glowing brightly in ultraviolet light. Hubble's sharp vision allows astronomers to monitor features of the star's atmosphere and better understand how it changes over time. Marking Orion's foot is another bright, hot supergiant, blue-white Rigel. Massive stars like Rigel lead short, brilliant lives. Below Orion's shining belt lies the Orion Nebula, a hazy spot to the naked eye. A small telescope reveals it to be a diffuse, glowing cloud in space, illuminated by the energy of bright, hot stars in its center. NASA's Hubble and Spitzer space telescopes reveal the nebula in festoons of glowing gas and dust sculpted by the stellar winds of central bright stars. The Orion Nebula is an immense stellar nursery filled with hot young stars that glow brightly in X-ray light detected by NASA's Chandra X-ray Observatory. Follow the belt of Orion down and left to find blue-white Sirius, the brightest star in the night sky. Sirius lies in the constellation Canis Major, the Great Dog, and companion to Orion. Sirius is also one of the nearest stars, just 8.6 light-years away, and has a faint white dwarf companion star. Just below Sirius lies a star cluster called M41. It is easily seen with a pair of binoculars as a scattered twinkling. M41 consists of about 100 stars that formed together from a giant cloud of gas and dust. Above and left of Sirius is another bright star, a yellowish giant named Procyon. Procyon is part of the constellation Canis Minor, the smaller dog, and Orion's second companion. Procyon, Sirius, and Betelgeuse form a geometrical pattern called the Winter Triangle. Let the Winter Triangle be your guide to the glories of the winter sky. Celestial wonders await you in tonight's sky.
So what we're going to do here is we're going to look at the star color and then the star's luminosity based off of the Hertzsprung-Russell diagram. So let's start by filling in the star color here. So number of stars present are 6, and our luminosity ranges from 1,000 to 10,000 suns. So 6 stars, 1, 2, 3, 4, 5, 6, and our temperature ranges from 1,000 to 10,000 on our y-axis. So this star color would be blue. So let's go back in and I will type that in. Going to our next star color, we have 7 stars with a luminosity of 0.1 to 1. Now remember, solar luminosity of a 1 would be our sun. So our range here would be right in here, and we're looking at these yellow stars, and we should find about 7. 1, 2, 3, 4, 5, 6, 7. So those would be yellow. Oops, let's put that up here. And then our next color or group of stars, we'd have 5 with a range of 0.01 to 0.1. So 0.01 to 1, we're looking here at this group of stars. These are going to be our orange stars. Okay, and then we're going to talk about luminosity now. So for our large white stars, we have about 6, and we want to know the luminosity range. So that's going to range from 0.1 suns to about 100. So you could type that range here. And then our small white stars, we have about 2. So our luminosity range for these guys would be 0.001. Going over to our large reds, we have 2, and our luminosity range would be about 10,000 suns. Our small red, we have about 6, and our luminosity range is about 0.01 as well. So what patterns do you see on the HR diagram? Well, you can see once you plot these stars by luminosity and temperature, a pattern forms. Stars are grouped based on their color, okay, and their temperature and size. Analysis questions. Characteristics astronomers use to classify stars on the HR diagram are going to be color, size, and temperature. The temperature of a blue star means that let's go back here. So the temperature of a blue star means that it is a warmer star. It's a hot star because it has a high temperature. So it also has a high luminosity. The temperature of a red star is, so let's go over here, and you can see on your x-axis your temperature range is about 3,000. So red stars are cooler stars. Okay, and here we have bright, cool stars. Down here, this group would be dim, cool stars. So which star are you? So let's plot yourself on the HR diagram. So let's choose an HR diagram that you would like to do for this assignment. We're going to copy and paste it to the right of slide 8. So you're going to choose which HR diagram you'd like to use. So I'm going to use the black and white one. So I'm going to right click and copy it. And then on my next slide, slide 7, I'm going to paste it here. Okay, and then I'm going to use this HR diagram to answer the questions to the left. So which group of stars are the brightest but a low temperature? So if we look over here at the spectral class M, lowest temperature up here would be around spectral class M up and down with a temperature of 3000. But your brightest ones are going to be your super giants. Super giants have a bright luminosity because they're found at the top of the HR diagram, but they are cool in temperature. Where do the majority of stars spend their lifetime? So the majority of stars spend their life as a main sequence star. And here you can see it's a diagonal strip or band that runs from very hot, bright stars to dim, cool stars in the lower right. The main sequence stars fit into a diagonal band that runs from the upper left to the lower right of the diagram. Our sun is classified as a main sequence star with a luminosity or brightness of a 1. Ask yourself the following question using the HR diagram as your rubric. If you were a star on the HR diagram, what color and temperature would you be and why? So this is kind of like a temperature check on how you're feeling. Okay, so are you kind of a dim star today with a low temperature, or are you going to be a bright, hot star today? Depending maybe on your energy levels, you can also do that. So, for example, my energy level is high, so I'm going to say that I am a bright blue star today. And how bright or luminous would you be and why? So I'm not super energetic or bright today. I would say I'm definitely above average, maybe around 100 luminosity. So using the star provided here, you're going to change its color to match the color that you choose for yourself and place it on the HR diagram in the correct spot. Make sure it matches the temperature and luminosity you choose for your answers. So I'm going to take that star and let's fill it. I would like to be a blue star. So I'm going to be blue because I'm going to be high in temperature today and also very bright because I need to be in full form in order to teach, right? I'm not going to give myself a super, super stellar brightness, but I'm definitely on the bright scale today with my thinking cap on. Let's go to slide number 9. It reads, Barnard's star is about 5.9 light years from the sun. The star has an approximate temperature of 2,800 kelvins. What spectral class does Barnard's star belong to? So here's temperature increasing from right to left on your x-axis, and then we have absolute magnitude or brightness going from bottom to top increasing. So we're looking for a temperature of about 2,800 Kelvin. So what spectral class does Barnard's star belong to? I'm looking at spectral class K because it's just above M, which is labeled at 2,400 kelvins. So spectral class M actually would be the answer that Barnard's star would belong to. So 2,400, about 2,800 would be around there. Okay, I hope you liked plotting yourself on the HR diagram today.